So today we're going to walk through an environment diagram, but for classes and objects. So this is the code on the right of the screen, and we're going to walk through an example which basically traces out the environment diagram for this code. So I encourage you to pause the video and try it out yourself first. Since this code is a bit too long to fit on the screen, I will post the link on our website so that you can go through it yourself. So assuming you've paused the video and tried it out yourself, I'm not going to walk through the solution. So in line 1, we start off like how we usually start off our environment diagrams. So we have this variable name in the global frame, and that name contains value Michelle. So it's string Michelle. And then on line 2, we have this class animal. So we have a variable animal which will point to the class animal whose parent is object. So it's the object class, so I've written that out over here. And we go inside this part, so we go to line 3 and we find this function called init. So we have this variable init which will point to func init with parameters self and size, and the parent is global because we are currently still in the global frame, and we know that from here. So this part is the global frame. Okay, we then have on line 5 this name variable. Remember that we've skipped line 4 because line 3 and 4 is a function definition and not a function call. So we don't go inside the indented part. So we come from line 3 directly to line 5 at this point. And on line 5, we have a variable name, which is animal, so the string animal. It's a string, so we've written that out over here. And then we have on line 6, age, which is 0. And line 7, we have another function called eat, which takes in 2 parameters called self and food. Alright, one thing I want to note is that self doesn't need to be called self. Self can be called anything. So I could name self even selfie. And I'm going to change this to selfie, just so you know that self doesn't need to be called self. Okay. So we have eat, and that's with parameters selfie and food. Okay. So then we go to line 10. And on line 10, we have our class bear. So we follow a similar process. So bear will point to class bear, and the parent of class bear is the animal class. So I could write animal here. And the first variable that we have in class bear is name on line 11. So I have name over here, and that's ASCII. On line 12, we have an attribute tail, which is true. Something to note over here is that since bear inherits everything from animal, so we know it inherits stuff from animal because animal is written over here. That means that it can use the functions and variables in the animal class. And it also means that bear can introduce its own variables which are not in animal. For example, bear has a tail and animal does not. So tail on line 12. And bear can also write its own variable values for variables or functions that exist in animal. So for example, we have in class bear the variable name, which is ASCII, but in class animal, name is animal. Bear uses its own name and does not use the name animal since it already has its own name. It doesn't need the name of animal. Okay, so we have this tail, and then on line 12 and on line 13, we have a function called eat, and eat is going to point to a function called eat intrinsically. So eat, and its parameter is food, and the parent is global, and that's because we're still in the global frame. Okay, so then we move on to line 15, and on line 15, eat is a function, but with different parameters, and it's actually a different function. So since we can only have one variable of the same name in a particular frame or class, we can't have two eat variables here. So you can't have eat and eat over here. This would not be valid. So we need to change one of the eats. So we change the eat we just saw and change that to the new eat. So I'm just going to remove this. And eat is now this new function, which is func eat with parameter self, food, and time. And the parent of eat is still global because that's the frame we're in right now. So we finished line 15 and we move on to line 17. And okay, on line 17 we have a function call. So the function call is a call to the function eat. So whenever we have a function call, we open up a new frame, okay, even though we're in a class. So I go to the other side. So this was my global frame initially that I was writing in, but now I need to open up a new frame. So let's open that up here. This frame is going to be called F1. This is just like our normal environment diagrams. And our intrinsic name of the function that was called is eat. So we write eat over here. And the parent was global. We also had three parameters. So it was self, then we had food, and we had time. Okay. So for those three parameters, we have three things being passed in. So we first have animal. Okay. So for animal, so we need to evaluate this value before we actually apply this function eat onto these parameters. So technically we should have drawn out this frame only when we've evaluated all of these arguments. So let's assume we didn't draw this out, and let's evaluate what animal is. Okay, so animal, we look in our current frame. So when we were on line 17, we were inside class bear. So we were here. And we need to look for something called animal. So we can't find animal here, so we go to the parent of class bear, and that's animal. And there's no variable called animal. So then we go to the global frame, and we see that animal points to this class, right? So animal is that class animal. So we know what animal is. So what I like to do is just point self to this animal class. Okay. So we have self. Now we have cake as our food. So I could write cake over here. And we have our time is a string called 5 seconds. Okay. So this is a string. Okay, so we finished line 17, and we're going to we open up this new frame called eat, frame F1, and we go inside this function. So that's on line 15. We go inside it, so we're on line 16 now, and we print self.name. Okay, so we need to look for self.name. So we look inside eat for the variable self, and we find it over here. So we then need to find the name of the self. So we follow the arrow of self, or whatever self contains, and now we search for the variable name, and we find name over here, which is animal. Yeah. So we know that self.name is the string animal. We then need to look for time, Okay, so we were still in the F1 frame looking for time, and we see that time is over here. So it's the string 5 seconds. So we have the string name, which is, so we have animal and we have this 5 seconds, and we're basically concatenating or joining the two strings together with this line. So the string will, the string we're going to use, which is going to be printed out, is going to be animal 5 seconds. So when we print this out in our display, so let's say this is our output. So this is our display screen. Okay, on our display or whatever's printed, we have animal 5 and seconds. Our function doesn't have an explicit return value, so by default the return value is none. So return value is none. And we finished going through this frame, so I put a tick mark over here. That's not compulsory, but I like to do it. Okay, we finished line 16 and line 17, and this is commented out, but I'm just going to explain it. So this line, so line 19, without the comment would have caused an error. So this would have caused an error specifically, and that's because our function on line 15, eat, takes in 3 parameters, and the function on line 19 takes in only 2. You might be wondering, why would it error even though the parent has a function called eat with 2 parameters? That's because even though the parent has a write function in a sense, this function that we've defined in our own class, so the function on line 15 and 16, overrides the function on line 7. So we only will try to use the function on line 15 and 16. And since we can't use it because of the fact that the arguments don't match the function call, so the number of arguments don't match, so that would error. Okay, so this part would error, and of course right now they're commented out, so we don't look at that yet. And we've essentially finished going through the whole of class bear. So we finished lines 10 to 19. Okay, so then we move on to line 21. On line 21, we're back in the global frame. We're no longer in these two classes. So we're back in global, and we have a function called eat. So eat is a variable, and it'll point to the function eat with parameters cherry and berry, and the parent of eat is global because we're right now in the global frame. Okay, great. So we don't go inside the indented part, so we do not go to line 22 because this is just a function definition and not a function call. We then move on to line 24. On line 24, we have a variable rando which equals animal 13. So we look at animal 13 and we evaluate that first. So we're still in our global frame, and the first part is to look for this animal thing. So we look in our global frame and look for animal. We find animal over here. So we found animal, and now we have this 13 thing. Okay, so when you have a class name, which is, so animal points to a class, and then you have perhaps nothing inside the class name or some arguments in the class name. So basically the structure is class name and parentheses. This means you're creating a new object or a new instance of the class. So in this case, what we're going to be doing is we're going to create a new animal instance. So animal class instance, it's the same thing as an object. So I'm going to call it instance of animal. So inst, so it's short for instance. So instance of animal. And what you could do next is, so what you have to do next is call the init method. So init is the same thing as initialize. So in our code right now, we do have an init method, but init may not always exist. If init doesn't exist, then you don't need to go through the init method because it doesn't have any side effects, so you don't need to keep track of anything per se. But we do have an init method right now, and the init method takes in these two variables. We need to store these variables in this object, and we also need to print, since that's what the init function is making us do. So we have an animal instance, and we have to open up the init method, so you need another frame because it's a function, right? So frame 2 is init, and the parent of init is going to be global, since we get that from here. And init has two parameters called self, and the other one was size. So self and size. Self will point to the animal instance. So we have this thing animal with this open parentheses. Self is just itself. You can think about it that way, which is the animal instance. So we don't point to the animal class, but instead we point to the animal instance that we have right now. We're going to create this. So that's self. And in general, whenever you have a class name or an open parentheses, you're going to be having a self being passed in as one of the arguments, even though it's not shown here. So there's just one argument that you can see explicitly over here, but there are actually two arguments being passed in. So we have the self, which is the instance of the animal, as well as 13 that's being passed in here. And that's why we have the self over here referring to the instance of the animal, and size is 13. So that's one occurrence where this would happen. We're going to come across more occurrences maybe a little later. Okay, so we have the self, then we have size, which is 13. And so we have to run this init function. So we come to line 4, and that prints size. So we need to look for the variable size here, and in frame F2. And in frame F2 we find size, and the size is 13. Okay. So we found size, and we need to print that because that's what the function makes us do. So we print 13, and then we return none because there's no explicit return value for init. So return none. Well, do we actually truly return none? We don't. So init is a special function, and the return value, unlike most functions, so whenever you don't have a return value in a function, usually it'll return none. But for init, it'll return the animal instance. So its return value will actually be this. It'll point to animal instance. And so that is returned to line 24. So this animal instance is returned. We finished this frame, so I put a tick mark there. And we have this return value being assigned to the variable rando in the global frame. So I'm going to have rando over here, and rando points to the animal instance. Okay, this is going to look a little messy, but hopefully you can follow along. So it's going to point all the way down there to this animal instance. Okay. Great. So that's rando now. And okay, so I've commented out these 3 lines because they don't work, but I'm going to walk through them. Okay, so if we just have bare and open 2 parentheses, this doesn't work. So usually when you don't have init, there's a default init method that exists, which you won't see. So for example, if I erase these 2 lines from my code, you wouldn't be able to pass in self and size, but there would still be an init method without any parameters. So just be init with 2 parentheses. You don't need to write it out explicitly, it'll exist in the code. Okay? And when that happens, these three lines, line 25 to 27, these three lines would have worked. So I could show you. Or let's say we didn't have the init method in animal. So I'm going to comment it out, and I'm going to comment out rando. Okay, so in this case, we have bear, and let's say it passes in nothing. Okay, so I've commented out lines 3 and 4 as well as line 25, because otherwise the code would error. So what we have now is so we were on line 30. On line 30, this won't error, because even though there are no init functions in any of the code, we have a default init that exists, and the default init takes no parameters. It will just return the instance of the class. So it will just return, in this case, bare instance, right? So OSCE would be bare instance. Yeah, so OSCE is bare instance. Okay, so that's what would have happened if this init did, but init exists in this case. So yeah, right, so I'm going to uncomment this and continue with our code. So this was bear 3 originally, I think. Okay, so now that we have bear 3, okay, I'm just going over here. We're on line 30 right now, so what's going to happen is on line 30, we're going to have a bear instance. So let's say I have inst bear. This bear instance has a parameter 3. So bear doesn't have its own init method, but it inherits methods from animal. So it will inherit the init method from animal. So we run the init function. So you open up a new frame, F3, with init function. Parent is going to be global because that's the parent of this init function. It has two parameters, self and size. Self and size. And like before, self will be the instance, but of bear, since bear is the object that's being created, so it's a bear instance, right? And we have size, which is 3, and our return value. So we need to first print something. So we print size. So size is 3, and our return value is just going to be the bear instance, because this is the init method that we're talking about. Okay. So OSCE is going to be a variable in our global frame that will point to this return value. So OSCE is a variable. It's going to point to the bear instance. So instance bear. Okay. So we're done with that. Okay. So now we're on line 32. On line 32, we see OSCE.emotion equals happy. Okay, so we search for OSCE in our global frame. We find it here, and we then trace the arrow. So this arrow in yellow, and it points to the bear instance. So the bear instance currently does not have the variable OSCE. It doesn't have the variable emotion, right? So we create a variable called emotion in this bear instance, and the value of this variable is happy. Note that we're not changing the value in the bear class, because this is just the emotion of the bear called OSCE, like this specific bear and not all bears. Okay. So this bear, the emotion of this bear is happy, and we then go to line 33. Something to note though is we're adding this new variable in the bear instance. So we're adding emotion over here as a variable. But if OSCI.emotion was on the right hand side of the equal to sign, so let's say A equals OSCI.emotion, we would then have to go, so we would look in our global frame for OSCI, so we find OSCI here, we trace this arrow, points to the instance of bear. Let's say this emotion was not here, okay? If this emotion thing was not here, we would need to look in our bear class for the variable emotion. And since we can't find it there, then we look in the parent of the bear class, so animal class, for the variable emotion. Okay, since we can't find emotion in the animal class, we throw an arrow. We do not look for the value of emotion in the global frame because we're asking for OSCI's emotion, not the emotion in the global frame. Okay, so we have OSCI emotion on line 30, okay, yeah, 33, sorry. Oh, 32. So we've changed that to happy, okay? Okay, so we have the emotion as happy. This was a line I just added, so I'm going to remove it. That was just to explain to you what would have happened in that case. Yeah, so we are on line 33 now. So we're looking for OSCI.age. So we look in our global frame for OSCI. We find OSCI here. Then we look for the variable age. And we look for that in our instance of bear. We can't find it here, so we look in the class bear for age. Can't find it there, so we look in the parent of class bear, which is the class animal for age. And the age is 0 in class animal, so we print 0. We're now on line 34, so that's OSCI.age. So we follow the golden arrow, find age, can't find it here. So since in this case on line 34, we technically have a variable on the left hand side of the equal to sign, which means that we will be creating a variable in the bear instance itself, because we can't change the value of all bears just because we're OSCI. We're a particular bear, so we can't change the value for all bears. So we have the variable age over here that's going to be created, and we initially do not have a value for age over here. So this line is the same thing as OSCI age equals OSCI.age plus 1, right? So we'd first look for OSCI.age. So we wouldn't have this age attribute here. So we'd need to go to the class bear, search for OSCI.age. Can't find it here, so we go to the parent of class bear, so that's class animal. And we find OSCI.age is 0. And then we add 1 to that. So 0 plus 1 is 1. And we now have a new variable called OSCI.age. So we write age over here. And that's going to be equal to 1. We next move on to line 35. So this is very similar in a way. So we first look for animal in our global frame. We find it here. Then we follow the pointer. And then we look for the attribute age. We find it as 0. But in this case, we're going to be changing this age here directly. And that's because we are animal, the animal class. We're not a specific animal instance. We don't have animal with 2 parentheses over here. This would be a specific animal instance. Since we don't have these 2 parentheses, we're the animal class itself, and we are changing our own age for all the animals. So we can change the age right here, and we change this. So this will be 0 plus 1, which is 1. Okay. And that's because this is an animal class and not an animal object. And an animal class doesn't have those 2 parentheses next to the class name. It just has the class name itself. So this is an animal object with 2 parentheses. An animal class will just be animal. Okay. All right. So that's an animal object with those 2 parentheses. And an animal class is without those 2 parentheses. We next move on to line 36. So animal.name. So animal is still a class. So we look here. We find animal. It points to this class. We look for name. We find it here. So we need to change this name. So the name is now going to be the string animal, but with 2 exclamation marks. So So you change the whole string to animal with 2 exclamation marks. Then on line 37, you have oski.name. So once again, look for oski. We find it there, follow the arrow. Look for a name over here. We don't find it. So we're going to have a new variable called name, because remember, oski can only change its own name since it's an object or a class instance and not a class itself, right? So oski was bare with 2 parentheses, indicating that it is an object. So oski is going to have the attribute name, right? We don't know what it is yet, but it's going to come here in the future. We first need to actually evaluate this part though. And this part, so we're still in the global frame on line 37, this part. Global frame, look for rando. We find it here. We follow the purple arrow. We're in the instance animal, and we then look for name. Since the instance of animal does not have a name variable, we look in the class animal, and we find that the class animal has the name for rando as animal with 2 exclamation marks. So we change. So we know what this evaluates to. So this is just a string called animal with 2 exclamation marks. So we just assign that to the variable oski.name. So over here, name will just be animal with 2 exclamation marks. Yeah. All right. Okay, so I've commented out lines 38 and 39 because they error. So line 39 will error. That's because when we try printing age, it'll search for age in the global frame and won't find the value, even though there is a variable called age in the animal class. So since it only searches in the global frame, it will not find a value and hence it'll error. Yep. So that's line 39. Then line 41. Once again, we look for rando. We find it here. Follow the purple arrow, and we have rando.eat. So we're in our animal instance. We go to the animal class since we couldn't find the variable eat in the animal instance, and we find the variable eat over here. But, okay, this is a function call. Since eat points to this function, it's a function call. Now remember that rando was an instance of a class or an object. Rando was animal with this open parentheses, right? So remember that all objects will basically pass in themselves as a parameter every time. So what's going to happen over here is there are actually 2 parameters being passed in to this function. There's the parameter self, which will refer to rando, which is an animal instance, and there's the parameter for name, which will actually point to, in this case, so let's look at our function. We have the attribute food. Okay, so selfie will be the animal instance and food will just be whatever name evaluates to. Okay, so let's try evaluating what name is. So we're still in the global frame. Remember on this line, we're still in the global frame. We're still looking for name, and when we look for name, we see that it's Michelle, right, over here. So we found name, and now we open up our frame for the function eat. So F4 has the function eat. It's the intrinsic name of the function, right, over here. And the 2 parameters are selfie and food. So eat has selfie and food, and the parent was global. Selfie will point to the animal instance, which rando points to, so it'll point to that. And food is just going to be what name evaluated to, which was the string Michelle. I'm food. Okay. Yeah. So we have line 41. We still need to evaluate the function eat, right? So we have a function call, and that function eat was here, line 7, right? Because it was animal.eat technically. If it helps, you might want to write animal.eat since we called the function eat in our parent class. So in the animal class, right? We called eat from the animal class. So writing animal.eat here helps you remember which class you called it from. Okay, So we have this function on line 7. We go to line 8, since we've already recorded the values of selfie and food, and we print. So we print selfie.name. So selfie is this. So it's the animal instance. We look for the variable name in the animal instance. We can't find it, so we go to the animal class, and we see that name is animal with 2 exclamation marks. Okay, and then there's the string yum. So we're just going to print out selfie.name, and selfie.name was animal, 2 exclamation marks, and plus yum, so yum will be right after that over here. All right, we finished that. Next, we move on. So we've basically evaluated line 41. So lines 42 to 44 I've commented out, but I'm going to just walk through them right now. So bear.eat with cake will not work, and the reason for this is that bear is a class and not an object. Remember, the difference between a class and object is that a class has no, so it just has the class name, so it'll just have bear, since that's the name of one of our classes. It won't have parentheses next to bear. But an object will be bear with 2 parentheses. Sometimes you might have a variable which is assigned to this object, so you could have rando, which equals bear with 2 parentheses, and rando itself is also an object because it points to an object. Okay, so in this case, when we have bear.eat, bear is a class, not an object, so there's just one argument being passed in, which is cake. There's no bear instance being passed in because this is a bear class. Okay, so we have bear, and then there's .eat cake. So we look for bear over here in our global frame. We follow this arrow basically. It comes here, and then we look for .eat. So we look for eat. The function eat is here, so we use this function. And cake is going to be passed in. There's only one variable, cake, but the function takes 3 parameters, as self, food, and time. Hence, this would arrow. Okay. Line 46. So on line 46, we have bear, and then we find bear over here. We follow the arrow as usual, points to the class bear. And then once again, we look for the function eat. So eat is here. And there are 3 arguments being passed in. So there's bear, cake, and 3 min. That means we evaluate each of these parameters. So we know bear. So we are still in our global frame, and we know bear points to the class bear. Then we have cake, which is a string, and 3 min, which is a string. So we're going to apply the function eat, which is bear.eat essentially. So I could write frame f5 is bear.eat. It has parent as global, just based off of this over here. And it has 3 parameters, self, food, and time, I think. Yeah. Okay, so we know self was just the instance of, sorry, it was not an instance. So self was bear, and bear was a class. So we need to draw a pointer to the class bear. So running out of colors, but I'm going to use maybe a light purple. So self will point to the class bear. Okay, I'm just going to go through this. Jeez. Okay, we're almost there. Okay, I'm just going to point it here. So it points to the class bear. Then we have the string cake, which is food. And for time, we have the string 3 min. Okay. So we go to this function, which is in class bear. So that's on line 16. We then go to the body of the function, and it's a print statement. So print is a function. We then see self.name. So we look for self in frame F5. And then we look for name in bear because that's what the purple arrow points to. So class bear has the name as Oski. So Oski is self.name and time. So we were in frame F5. We look for time. And time was 3 minutes. 3 min. String 3 min. So we're going to be printing that. So that's Oski 3 min. Oski 3 min. Right? We printed that, and a return value, it's just a normal function inside of bear, so our return value would be none. It's not the init function. Okay, so that's why we return none. Great, and that's it, because we've reached line 46. We finished line 46. We finished going through this frame, and we've essentially finished going through all our frames. I forgot to put tick marks here, but you don't need to, of course. Oh wait, actually, something looks weird. I forgot to put a tick mark there, which means I don't have a return value either, which means I forgot something. So selfie. Okay, animal eat was parent global. So animal.eat, so it was here, and it was this. I think I printed something.yum. Pretty sure. Yeah, I printed something with yum, but I forgot to return a value. That's why these tick marks are so helpful. When you forget to return values, so this will return the value none because it's just a normal function. It's not the init function, and it doesn't have an explicit return value. And F3, yeah, I just forgot to put a tick mark for F3. It returns its value. And everything else has a tick mark, and I finished going through everything in the global frame. All my frames have tick marks now, so I know I finished everything. Yeah, so that's basically how you draw out environment diagrams for classes and objects. It took a bit of time, but it's a very useful skill, and especially on exams when they try to trick you. This method takes a little bit of time, but at least you'll get the problem right if you use this method rather than use very little time, get the problem wrong. Okay, thanks for watching.